Hello students, myself Qno.1 and you are watching Tomachang tutorial. So we are going to start a new chapter and that is Indices, exercise 7a. Okay, Indices is the plural form of index. Index means power. Okay, index means power. So a to the power 2 means the index of a is 2. Index means the power. So index is the singular form and indices is the plural form. So we are going to learn about the powers in this chapter, isn't it? So let's begin with the rules. Let me tell you some rules of the indices which we need while solving the problems in this exercise. Okay, number 1 is a to the power 0 equals to 1. That means anything to the power 0 equals to 1. Okay, except 0 to the power 0 is not equal to 1. Exception is 0. And other than 0, anything to the power 0 is equal to 1. Let me explain this. If a to the power 0 equals to 1, then 1 to the power 0 equals to 1. 5 to the power 0 equals to 1. X to the power 0 equals to 1. 1000 to the power 0 equals to 1. Anything to the power 0 equals to 1. Okay, but 0 to the power 0 is not equal to 1. Is not equal to 1. Please remember this. 0 to the power 0 is undefined. Is undefined. 0 to the power 0 is undefined. 0 to the power 0 is not equal to 1. Other than 0, anything to the power 0 is equal to 1. Okay. Any number raised to power 0 equals to 1. Please keep this in mind. This is rule number 1. Okay, and we will move on to the next rule. The next rule is a to the power m whole to the power n equals to a to the power mn. Let me explain you. Suppose we have 2 cubed whole square. Okay, we have 2 cubed whole square. Suppose 2 is a and this is m and this is n. According to this rule, a to the power m whole to the power n is a to the power mn, isn't it? This gives us 2 to the power mn, means 3 into 2 is 6. So if the power is written like this, that means you can multiply the power as it is. 3 to the 6. Okay, this is very simple, isn't it? So now let's move on to the next rule. A to the power m into a to the power n is a to the power m plus n, which means if the base are same, a to the power m into a to the power n, here the base are same, so their powers will get added, m plus n. Let's take an example. Suppose 2 squared into 2 to the power 3, 2 to the power 3, 2 squared into 2 cubed. Here the base is 2 and 2, base are same, so we can add up the power, 2 plus 3. That gives us 2 to the power 5, isn't it? And 2 to the power 5 means 32, isn't it? 2 multiplied 5 times. 2 into 2 into 2 into 2 into 2 into 2, isn't it? 1, 2, 3, 4, 5. Oh, not 6, 5 times. 1, 2, 3, 4, 5. 2 multiplied 5 times. 2 to the power 5 means 2 multiplied 5 times. Let us check. 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32. 2 to the power 5 means 32. Now let's check from this. 2 squared means 4 into 2 cubed means 2 multiplied 3 times, that is 8. 2 to the 4, 4 to the 8, 8. So 4 into 8 is 32, isn't it? So when the base are same, their powers can be added like this, 2 plus 3, 5. Okay, I hope you got this. Now let us move on to the next rule. The next rule is a to the power m divided by a to the power n is a to the power m minus n. A to the power m divided by a to the power n equals a to the power m minus n. This is actually a to the power m whole to the power, whole upon a to the power n, isn't it? Divide means upon. So when you bring the number from the denominator to the numerator, okay, when you bring the number from denominator to the numerator, the sign of the power changes. If this is plus, then this becomes minus. Now here you can see the power of a is plus n, a to the power m is already in the numerator, into this a has the power plus n. When you take this to the numerator, the sign of the power changes to minus n, isn't it? So the base are same, that means power can be added, a to the power m plus, and this is minus n, isn't it? So this gives us a to the power m, plus into minus is minus, and this is n, isn't it? This is what comes a to the power m minus n, how it comes. Okay, I hope you got this. Now what I mean to say from this is, when you take any number from the denominator to the numerator, the sign of the power changes. Similarly, if you take any number from the denominator to the numerator, the sign of the sign of the power changes. Okay, suppose, let me give an example, one more example. 1 upon m. What is the power of m here? Obviously plus 1, isn't it? So if you take this m to the numerator, you can write as m to the power minus 1. Okay, this m was in the denominator. When you take this m to the numerator, the sign changes. The power of the sign of the power changes to minus 1. Okay, suppose this is m square. Now if you take this number to the denominator, the sign of the power changes to the minus 2. Suppose this is m to the power minus 2. If you take to the numerator, the sign of the power changes to plus 2. Similarly, if the number is in the numerator, m square, then you can write this as 1 upon m to the power minus 2. Okay, from this relation we should understand this phenomena, this system. Okay, if we do not understand this, then this relation is useless. Now let us move to the next one. A to the power m into b to the power m can be written as ab whole to the power m. Okay, this means if 2 squared into 3 squared, okay, 2 squared into 3 squared, if the number is 2 squared into 3 squared, now this 2 and 3 remains as it is 2 into 3. Now the powers are same, so you can put the power 1 power here. 2 into 3, sum up, and 1 power. Okay, sum up means not add. 2 into 3 will remain as it is, into, and the power is written only once. So this means, let's prove this whether it is wrong or not. So this means 2 3s are 6. 6 square, isn't it? So 6 square is 36. From this relation we got 36. Let us check whether it is 36 or not. 2 square means 4. So 3 square means 9, isn't it? Sorry, this is into here. 3 square means 9. So 4 9s are 36. Are you getting me? So this is also 36 and this is also 36. That means you can add up the number, not add up, you can write the number like this within the bracket and put the power only 1. Okay, this can be done. Okay, the similar thing we sometimes do like this also. A to the power m whole upon a to the power m, sorry, b to the power m. A to the power m whole upon b to the power m. Here we have the power same, isn't it? So this can be written as a upon b whole to the power m. Okay, a to the power m upon b to the power m can be written as a upon b whole to the power m. Now since both the numbers a and b are within the bracket and the power is outside the bracket, that means this power m applies to both a and b. So a to the power m and b to the power m. I hope you got me. Now let us move on to the next rule. The rules are very simple. So root a can be written as a to the power 1 upon 2. Okay, if the number is under a square root, this square root can be written as 1 upon 2. If this is cube root of a, then you can write 1 upon 3. Okay, if this is fifth root of a, this is called fifth root of a, then you can write a to the power 1 upon 5. Okay, now what do I mean by this is, if this is 4 root, okay, if this is 4 root, what we do is 4 root means 2, isn't it? The value of 4 root is 2. root under 4 means 2. So instead of this writing directly like 2, by applying the rule of indices, how do we write? 4 can be written as, root under 4 can be written as 4 to the power 1 upon 2, isn't it? Root under 4 can be written as 4 to the power 1 upon 2. Now 4 means 2 square. So 4 means 2 square. This is 2 squared into 1 upon 2, isn't it? 4 can be written as 2 square. 2 to the 4, and this 1 upon 2 is already here, 1 upon 2. So 2 and 2 cancels out, and 2 to the power 1. 2 to the power 1 means 2, isn't it? So root under number can be written in the form 1 upon 2, okay? Or if this is cube root, and should be written as 1 upon 3. If this is fifth root, 1 upon 5, and so on, okay? I hope you got this. Very, very simple, isn't it? Now let us move on to the next one. If a to the power m equal to a to the power n, okay? Here a to the power m equals to a to the power n, the base are equal, isn't it? A and a. If the bases are equal, then definitely powers will be equal. Please keep this in mind. We require this while solving, okay, the numericals from this chapter. I think from the next chapter. If a to the power m equals to a to the power n, then the power will be equal. If the bases are equal, then the powers will also be equal. But please note this: if a to the power m equals to b to the power m, if the powers are equal, then it is not necessary that bases should also be equal. In this case, if a and a base are equal, then powers will become equal, isn't it? But if the powers are equal, then it is not necessary the bases should be equal, okay? Keep this in mind. Sometimes bases may be equal, sometimes bases may not be equal. Okay, now this much is the rule for indices. Now let's move on to the exercise. Okay, let's begin with the question from this exercise 7a. Number 1 is evaluate. Evaluate means calculate. Calculate the value of this expression, okay? Calculate the value of this numeric expression. So we are asked to calculate the value of this expression. Let's simplify this. 3 cubed we write as it is 3 cubed. 243 can be written as 3 to the power 5, okay? 3 to the power 5 is 243. How do we get this? Let me tell you. 243 is written as like this, and we find the factors of 243, okay? 3 8s are 24. We know this, isn't it? You know this very well. 3 8s are 24. 3 1s are 3. 3 2s are 6. 7 8 2. 3 7s are 21. 3 9s are 27. 3 3s are 9. So 1 2 3 4 5. 3 multiplied 5 times means 3 to the power 5. Okay. So into 243 can be written as 3 to the power 5. Okay. Now into minus 2 upon 3. Minus 2 upon 3. We must be very, very careful with the sign. Okay. Minus 2 upon 3. Into this into comes here. 9 means 3 squared, isn't it? 3 squared is 9. 3 3s are 9. Into minus 1 upon 3. Now please keep this in mind. This 5 is the number in the numerator and this 3 is the number in the denominator, okay? Because there is no number in the denominator means we should understand there is 1, okay? We need not write this 1, but we should understand that this is the number in numerator and this 3 is in the denominator, 2 is in the numerator, 3 in the denominator, this 2 in the numerator, okay? Now let us simplify this. 3 cubed into 3. Now let us multiply the numbers in the numerator. Plus, there is plus sign in front of 5. No sign means plus sign. Plus into minus. Minus 5 2s are 10 upon 3, isn't it? Into this 3 comes here. 2 plus sign again. Plus into minus. Minus 2 1s are 2 upon 3. Are you getting me? Yes, why not? So this 3 3 3 same number, isn't it? If the bases are same, then the powers can be added. So let us add up the power. 3 plus minus 10 upon 3, isn't it? Plus minus 2 upon 3. We write it like this: the power of this number plus the power of this number plus the power of this number, isn't it? So plus into minus becomes minus, and this also plus into minus becomes minus, so no need to write all these things. We straight away write like this: 3 cubed minus 10 upon 3 minus 2 upon 3. Sir, instead of adding, why did you subtract the number? Don't say like that, because we added up and the sign got changed, isn't it? Plus into minus became minus. So 3, this 3 minus 10 upon 3 minus 2 upon 3. Okay, now we have 3 in the denominator. So the LCM of 1, 3 and 3 is 3. This 3 we write a little bigger, and the LCM is 3. Okay, how do we find the LCM? 3 comma 3 comma 1. 3 1s are 3, 3 1s are 3, and this one comes here. 3 1s are 3, 1s are 3, 1s are 3, isn't it? The LCM is 3. So the LCM is 3. That means 1 into what number is this? 1 into 3 is this, isn't it? So that 3 into this 3 is 9, minus 3 into what number is this? 3 into 1 is this, so 1 into 10 is 10. So this minus comes here. 3 into 1 is this, so 1 into 2 is 2. So this 3 we write a little bigger. So here we have 2 is minus and 10 is also minus, but this 9 is plus. That means we add up the negative ones and subtract from the positive. Okay, minus 10 and minus 2 is minus 12 and plus 9. Minus 12, let me explain this. 10 is minus, 2 is minus, that is minus 12. Minus 10, minus 2, number gets added but the sign will remain minus. 10 minus 2 is minus 12, and this is plus 9, isn't it? Plus 9. So the signs are different, that means we must subtract. 12 minus 9 is 3, and the sign of greater number comes here, that is minus 3. So in the numerator we have minus 3, and in the denominator we have plus 3. So 3 and 3 cancels out, the power remains 1, isn't it? So this means 3 to the power minus 1, isn't it? 3 to the power minus 1. As I told you earlier, if the power is minus 1, you can take the number to the denominator and the sign of the power changes to plus 1. So if the power is plus 1, no need to write that. So the value is 1 upon 3. The power of this 3 is minus 1, and this number is in the numerator, because 1 in the denominator, there is 1 in the denominator. Okay, now if we take this 3 to the power minus 1 to the denominator, the sign of the power changes to plus 1. And if the sign is, if the power is plus 1, so no need to mention that plus 1. That means 1 upon 3 is the answer for question number 1. Okay, I hope we got this. Now let us move on to the next question, that is question number 2. Question number 2, we have 5 to the power minus 4 into this 125 can be written as 5 cube, isn't it? Excuse me. So 125 we have here 5. Since the last digit or the unit digit number is 5, so we can divide by 5. So the factors are 5 2s are 10, 11 12 2, 5 5s are 25, and 5 5s are 25. So 1 2 3, 5 multiplied 3 times gives us 125. That means 5 to the power 3. 5 to the power 3, that is 5 cubed, isn't it? 125 means 5 cubed into, we have 5 upon 3 already. 5 upon 3 we copy as it is, divided by this 25 can be written as 5 squared, isn't it? 25 means 5 5s are 25. So 25 can be written as 5 squared into minus 1 upon 2. Okay, I told you earlier, you must be very careful with the sign. If you miss any sign, then the answer will come another thing, that is wrong thing. Okay, let's cancel out this 3 and 3, because this 3 is in the denominator and this 3 is in the numerator. So let's cancel out this 2 and 2. Okay, this 2 is in the denominator and this 2 is in the numerator. So let's write the remaining 5 to the power minus 4 into 5 to the power 5, isn't it? This is to the power 5. 5 to the power 5, 3 3 cancelled, divided by, so we have 5 to the power minus 1, 5 to the power minus 1, isn't it? 5 to the power minus 1, 2 2 cancelled, 5 to the power minus 1. So instead of writing this 5 to the power minus 1, why should not I write 5 to the power plus 1? Isn't it? Are you getting me? The power of 5 is -1. So why don't I write this 5 to the power -1, 1 upon 5? If you take this 5 to the power -1 to the denominator, the sign of the power becomes +1. So +1, no need to write +1, 5, isn't it? So this gives us 5 to the power -4 into 5 to the power 5 we have here. Let's now change this divide into multiplication sign, okay? What happens is the number from the denominator goes to the numerator, isn't it? And the number from the numerator comes down to the denominator. So no need to write if there is 1. So here the power is 1, isn't it? If there is no power, we should understand there is power 1. So the bases are same, 5, 5 and 5. The powers will be added. 5 minus 4 plus 5 minus 4 plus 5 and this plus 1. Are you getting me? 5 to the power. This 5 and 1 is positive. So plus 5 plus 1 plus 6. And this 4 is negative. So 6 minus 4 is 2. 5 square means 25, isn't it? So this is the answer for question number 2. Now let us do question number 3. We are asked to evaluate these numbers. Okay, very simple, isn't it? 27 can be written as 3 to the power 3. 3 cubed is 27. 27 means 3 cubed. 3 9s are 27. 3 3s are 9. 3 multiplied 3 times gives us 27. So 3 cubed, isn't it? Upon 125 means 5 cubed. 125 means 5 cubed. 5 2s are 10, 11, 12, 2, 5 5s are 25. Again 5 5s are 25. So 5 multiplied 3 times gives us 125. This means 125 means 5 cubed. 5 cubed is 25. So the power is 2 upon 3, isn't it? 2 upon 3, the power remains as it is. Into, this into comes here. 9 means 3 square and 25 means 5 squared. 3 squared is 2 3s are 9, 5 squared is 5 5s are 25. So the power is minus 3 upon 2, minus 3 upon 2. I hope you are getting me. Now, since we have seen the rule earlier that if a to the power m upon b to the power m, then we can write a upon b whole to the power m, isn't it? If the power are same, a upon b, then power can be written within the bracket, okay? Sorry, the numbers can be written within the bracket and the power is written only once. So this 3 and 3, the powers are equal. So let's write 3 upon 5 and whole to the power. This 3 and 3, we write 1 3 here, okay? This 3 and this 3, we write 1 3. Into, we already have 2 upon 3. We should not forget that 2 upon 3. Into this 3 upon 5, the power is square and square. So let's do the same thing here. 3 upon 5 whole squared. 2 2 2 1 2, okay? Into, we already have minus 3 upon 2, minus 3 upon 2, isn't it? So let's cancel this 3 and this 3 because this is in the numerator and this is in the denominator. And same thing goes here. 2 2 cancels out. So here the power, the number is 3 upon 5 whole squared. 3 upon 5 whole squared into 3 upon 5 minus 3. Minus 3. The power is minus 3 here. 2 2 cancelled out. Minus 3 is left now. Now the bases are same. 3 upon 5, 3 upon 5 base are same. So the power should be added. 3 upon 5, 2 minus 3, isn't it? The power should be added. 2 plus minus 3, 2 plus minus 3. Powers is added, okay? Plus into minus becomes 2 minus 3. I hope you're getting me. Plus 2 minus 3, 2 minus 3. Now let me continue here. 3 upon 5, 3 upon 5. Plus 2 minus 3 is minus 1, isn't it? So this means power is, if the power is minus 1, the number actually, what happens is 1 upon 3 to the power 5 whole to the power plus 1, isn't it? This power is minus 1. If you take the whole number to the denominator, the sign of the power changes to plus 1. I told you earlier. Now what happens is this 5 goes to the numerator, upon 3 comes down, isn't it? That means this 3 upon 5 whole to the power minus 1 can be written as 5 upon 3. Are you getting me? 5 upon 3, which gives us 3 ones are 3, 2 upon 5. Sorry, 3. 3 ones are 3, 4, 5. 5 upon 3. Are you getting me? This is an improper fraction because the number in the denominator is smaller than the number in the numerator. So we must convert this type of fraction into mixed fraction. How do we convert this? I hope you know this very well. 3 ones are 3. 5 minus 3 is 2, isn't it? Now this quotient 1 remains here. This remainder 2 goes up and this divisor 3 comes down. 1 whole 2 upon 3. The same thing 1 whole 2 upon 3. I am writing it. So the value of this expression is 1 whole 2 upon 3. I hope you got this. Let's do question number 4. We have 7 to the power 0 into 25 to the power minus 3 upon 2 minus 5 to the power minus 3. We must be very careful with the sign, okay? So 7 to the power 0 means 1, isn't it? Anything to the power 0 is 1. I told you earlier in the rule, a to the power 0 equals to 1. Any number raised to power 0 is equal to 1 except 0, okay? 0 to the power 0 is not equal to 1. Please remember this, 0 to the power 0 is undefined. Other than 0, any number raised to power 0 is equal to 1. So 7 to the power 0 is 1. So you can write this equals to 1. 7 raised to power 0 is 1 into 25 can be written as 5 square. 5 square, this is not minus, okay, this is 5. My style of writing 5. 5 square, 5 5s are 25. Into minus 3 upon 2, minus 3 upon 2. This minus comes here, 5 to the power minus 3, isn't it? So this 2 and 2 cancels out because this 2 is in the numerator and this 2 is in the denominator. 1 into 5 means 5, isn't it? 1 into anything is that thing. 1 into u is u itself, isn't it? So 1 into this is this. So 5 to the power minus 3. 5 to the power minus 3. Here we have 5, 2 is cancelled, 5 to the power minus 3. Minus 5 to the power minus 3, isn't it? So this is 5 to the power minus 3 and this is 5 to the power minus 3. This is positive and this is negative. This gives us 0, isn't it? 2 minus 2 means 0. If the value of the numbers are equal and the signs are opposite, then the number becomes 0, isn't it? Here the value of the number is 5 to the power minus 3. 5 to the power minus 3, the same number, and this number has the sign negative and this number has the sign positive, so this becomes 0. So the answer for question number 4 is 0, okay? That is question number 5. We have this expression, numeric expression, and we are asked to find the value of this expression, isn't it? So let's do. 16 can be written as 2 to the power 4. Let's see here. 16, 2 8s are 16, 2 4s are 8, 2 2s are 4. 1 2 3 4. 2 multiplied 4 times gives us 16. That means 16 can be written as 2 to the power 4 whole upon 81, isn't it? This is 81. 81 means 3 raised to power 4. 81 means 3 2s are 6, 7 8, 3 7s are 21, 3 9s are 27, 3 3s are 9. 1 2 3 4. 3 multiplied 4 times gives us 81. So 81 means 3 to the power 4 whole to the power minus 3 upon 4, isn't it? Minus 3 upon 4 into 49 means 7 7s are 49. That means 7 squared. So 9 means 3 squared, 3 3s are 9. 3 squared gives us 9, 3 3s are 9, whole to the power 3 upon 2 divided by 343. 343 means I think so 7 cubed is 343. 343. 7 4s are 28. 29, 30, 31, 32, 33, 34. 6 left, 63. 7 9s are 63. 7 7s are 49. So 7 multiplied 3 times gives us 343. Instead of 343 I write 7 cubed. Okay. So 216 means 216. Let us find the number by 6. 6 3s are 18. 6 3s are 18. 19, 20, 21, 3, 36. 6 9s are, oh, 6 9s are 51. 6 6s are 36, isn't it? 6 6s are 36. Again 6 6 6 are 36. So 6 multiplied 3 times gives us 216. That means 6 cubed whole to the power 2 upon 3, isn't it? So now I told you earlier, since a to the power m whole to the power whole upon b to the power m can be written as a upon b whole raised to power m. This m and m were written separately, but you can put both the numerator and denominator within a bracket and put the power only 1, isn't it? So let's do the same thing here. 4 and 4, let us write only 1 power 4 and put this 2 and 3 within a bracket, okay? 2 and 3, 2 upon 3, and this 4 and 4, 1 4 into minus 3 upon 4, minus 3 upon 4 into 7 upon 3. We do the same thing here. 7 upon 3, this square and this square we write 1 square into 3 upon 2, 3 upon 2 divided by the same thing here also. 7 upon 6, 7 upon 6, this cubed and this cubed we write only 1 cube into 2 upon 3, isn't it? So now let us cancel this. 4 and 4, 2 and 2, 3 and 3. So this gives us 2 upon 3 whole to the power minus 3, isn't it? 2 upon 3 whole to the power minus 3, that means 3 upon 2 whole to the power plus 3. Are you getting me? 2 upon 3 whole to the power minus 3, that means if you take to the number to the denominator, the sign of the power changes. I told you earlier. So when it goes to the denominator, this minus 3 becomes plus 3. Now the number gets inverted, 3 upon 2 to the power 3. I hope you got this. Now 7 upon 3 whole cubed, 7 upon 3 whole cubed, isn't it? Into, okay, this, which number is this? 6, isn't it? 6. This divide can be written as into. Now this 6 goes to the numerator, 7 comes down to the denominator. 6 upon 7 whole squared. Divide, you change the sign into multiplication. Now this 7 upon 6 becomes 6 upon 7 whole squared, okay? Now let me continue the sum here. So this 3 cubed I write as it is, 3 cubed upon 2 cubed upon 2 cubed, okay, into this 7 cubed, isn't it? 7 cubed upon 3 cubed. This cubed is for both 7 and 3, isn't it? So 7 cubed, 3 cubed is 3 cubed, okay, and 6 square into 6 square upon 7 square, isn't it? 7 square. So here we have 3 cubed and 3 cubed, same number. Let us cancel this. So now this 7 square goes to the numerator, becomes 7 to the power minus 2, and the base will be 7 and 7, the power will get subtracted. So 7 to the power 3 minus 2 is 7 to the power 1. Or you can say like this, here we have 2 7s and here we have 3 7s. So 2 7s and 2 7s get cancelled, 1 7 remains here. That also you can do, okay. Now here we have 6 square and 7, which cannot be cancelled with this, okay. 6 square we write as it is, okay. This 7 here, let me write clearly, 7 into 6 square means 36 upon 2 to the power 8 means 2 to the power 3 means 8, isn't it? So 4 2s are 8, 4 9s are 36, 4 2s are 8, 4 9s are 36. 6 square means 36. Now 7 9s are 63 upon 2. Now this is also an improper fraction, so we must convert this into either decimal or mixed fraction. If we want to convert this into mixed fraction, then it happens 31 whole to 1. 2 31s are 62 plus 1 63 upon 2. 31 whole 1 upon 2. or you can say 31. This is 1 upon 2 means half, 0.5, isn't it? 31.5. If you didn't get me what I meant to tell you here, then I'll show you here, okay? If you didn't understand here, I'll show you here. 63 upon 2. 63 upon 2. If you couldn't understand here, I'm just showing here, okay? Again, 2 3s are 6. So this minus 6 and 6 goes 0. This 3 comes down here. Now again, let us divide. 2 1s are 2. 3 minus 2 is 1, isn't it? So you can put the decimal here and put 0 here. 2 5s are 10. 10 minus 10 is 0. So 31.5. This is 31.5. Okay? I hope you got this. So let's do this much for today. Thank you so much for watching this video. I hope you understood the concept. I hope you understood the method which I tried to teach you. If you understood the method, if you like the way of my teaching, then don't forget to subscribe the channel and click on the bell icon to get notifications for more educational video uploads. Okay, thank you.